Welcome to Data Science Now, a podcast by Closter about the latest trends in data science with your host, Fabio Vasquez. Today, we'll talk about how to learn and use the most important Python libraries for data science, like TensorFlow, Pandas, Spark, and many more. Follow us on social media at Closter Team. This is Data Science Now.
Hello and welcome to a new session of Data Science Now. We are in the 4th episode right now, and it's always a thrill to be here with you. Remember that we'll be always live here every Wednesday, 8 p.m. CST. Check that up to see what's the time zone for you. And in today's episode, I'll be talking about something very interesting. The idea is to talk about Python and its libraries for data science. In the past episodes, I've been discussing the history of data science, what's data science as a field, and we briefly discussed the importance of Python in the development of the field. Now, I want to go deep into some of the best libraries we have for the language. Just a quick note: you can see all of the episodes that we have so far. They're on YouTube. You can find them on Closter. You just have to type Closter and you'll find our channel. We'll put more information there and more videos, but you'll find there the episode of Data Science Now. And you can find us on Spotify and more places. Okay, so let's get started. I think the first thing I would like to talk about is the importance of Python as a language for the field of data science. As you may know, Python is a very important language, not only for data science, but for the world right now. Most companies in the world are using Python to do what they're best at. And also, I think it's becoming a standard at schools, universities, and courses because it's a very simple language to use, but very powerful. But that power comes not only from the language itself, but from the libraries you can use with the language. And in here, I'll discuss the best ones we have for the language, how to learn those libraries, and some new features and more libraries that you have to be aware of that people will use in the near future for data science. One of the cool things from Python is that it's a complete language. If you compare R with Python, and I think that's a fair comparison, I think that the most important difference is that Python is a language that can be used for everything. R is a domain-specific language. That means that Python can do everything, and R is focused on the world of statistics. Don't get me wrong. The R language is a very important language, and you can do a lot of different things with it. But if you want to have a complete tool in your hands to do stuff, you have to use Python. So let me get started with maybe the most important library for data science in Python, and that's Pandas. Pandas, as the animal, is the library we have in Python to read and work with information. We'll discuss more of Panda-like libraries in this session, but I think it all started from Pandas. I think before Pandas, another important library that you really want to understand, and we'll get back to Pandas in a second, is Numpy. Numpy is the library that you have in Python to work with numerical information. You have matrices, matrix operations in Numpy, and you can do almost everything you can think of, like derivatives and numerical computation with that library. But when people wanted to go to a different place, when they were starting to read information like from CSV or Excel files or JSONs, they realized they needed something similar to what R was doing and what MATLAB was doing at the moment. And that was having the concept of a data frame. And the data frame is, I think, the most important concept we have when we use Pandas. And is this a spreadsheet-like type of information where you have your columns and your rows with all the data you can read from. And you can read with Pandas from the web, from the hard drive, or from a different location you have in your computer. So what do you need to know about Pandas? And I think we have to go right now, and this is one of the news for the episode, is that finally we have Pandas version 1.0. After years of development, finally the Panda people have released the 1.0 version of the library, and that contains that contains more cool things and fixes that were expected from years for some people. One of the cool things you can do with this new version of Pandas is that you have string types. If you know a little bit from Python, you know that Pandas inherited the concept of an object. And he did it because in the insides of Pandas you have Numpy, and Numpy is using the object type of data to store things like dates and strings. And it was kind of weird when you were using Pandas and you didn't have this string type object and you were not sure if that was a date or not. So you had to do some transformations. But now you do have that a string type that we waited for so long. Other cool thing you have now in Pandas 1.0 is that you can convert to Markdown. If you don't know what's Markdown, Markdown is the standard language we use for documenting things in notebooks like Jupyter. Markdown is a tag language like HTML that can help you to format information. And one of the cool things is that sometimes you had your information in Pandas and you wanted to put it in a different place or have it as a markdown, and you had to copy paste it. But now you have the simple function df dot to markdown, and that's it. You have more experimental features for NAs. Now, as I mentioned, we have the string data type. Now we have the Boolean data type with the support for missing values, and you are now able to use the convert D types and to support more extensions of types. If you want to read everything that I'm just mentioning, you can search online for Pandas 1.0, and you'll find the web page from the library telling about the different things that they added. By the way, if you have any questions, you can put them here on LinkedIn right now, and I'm going to maybe answer them in the end of the session. So I started with Pandas because, of course, it's the most important library we have in the language for data because it's the most used one, but it has a huge drawback. And the drawback you have from Pandas is that it doesn't work for big data. And I mean, when I say big data, people start thinking, okay, terabytes. No. If you have like 5 gigabytes of information, it's going to be very, very hard to read that in Pandas. So, and this is important for you to know. A lot of people learn the data science world of Python with Pandas, and then when they have to go to a new company or they have more information, it gets very hard for them to go to new libraries because they're so used to one library. And one of my recommendations is that don't marry to any library. Learn as much as you can from different libraries and try to find the best fit for your problem. So before going into what do we like the solutions for this big data information stuff for Pandas, I want to complete the ecosystem for Python. A normal ecosystem for Python is this one. You use Numpy for numerical computations. You have Pandas for data, cleaning information, all of this. You have Matplotlib and Seaborn for plotting. Matplotlib is a very important library for Python because it's the most important library for plotting we have in the language. It's the standard one. It's not that beautiful. I mean, you can compare it with different libraries, and you'll find it's not the most beautiful library in the world. But something interesting that you can find in Matplotlib is that it's very. You have a lot of custom ways of changing your plots, and it's very flexible. The other library I mentioned for plotting is Seaborn, that is based on Matplotlib, but is more focused on the world of plotting for statistics. Like you want to do a scatter plot, you want to do a bar plot, a violin plot, a box plot. That's much simpler to do with Seaborn than with Matplotlib. We have another library that's getting more and more attention for plotting in Python. It's called Plotly. Plotly has an API for R2 and for JavaScript as well. But the Python library is very, very cool. The cool thing about Plotly is that you can create interactive plots. I mean, you don't create like these static plots that you can see. They may be very cool from Seaborn or Matplotlib, but what if you wanted to interact with the plot? With Plotly, that's very simple. So far we have Numpy, we have Pandas, Matplotlib, we have Seaborn, and we have Plotly. There's I think the other standard libraries are most focused on the world of statistics and machine learning. One of the most important ones is Sci-Fi, and Sci-Fi is a library you have for not only doing statistics, but you can do science with it. You can do derivatives, you can do integrals, and you can do all of these like complex things we have in math with Sci-Fi. It has different sub-libraries like modules that you can use to do different things with the information you have. Then we have stats models. Stats models, sadly, I think this is a sad thing for the library because it's a very important one, was very overshadowed by the other one that is called scikit-learn. Scikit-learn is the default library for Python for machine learning. And the thing here is, if you really want to master the world of data science with Python, you really want to understand scikit-learn. Scikit-learn has almost every known and used algorithm for machine learning that we use in companies, in the industry, you use in the academy, and it's a very straightforward library to use. It's simple to understand, and it has some concepts that you will see in other libraries that I'll talk about in a few minutes. And those concepts are the ones of pipelines, like dividing your work in different pieces and then combining them together to create a pipeline. The concept of estimators, the concept of transformers, all of that is present in different libraries that we'll talk in the near future. But I think most of the ideas we had for creating these new libraries came from scikit-learn. The cool thing about stats models that I mentioned briefly is that you have this art-like world. When I mention the art-like world, is that if you are using R, then you're used to create formulas for your algorithms. Let's say you have a general linear model and you want to fit a line to some for some data. You're used to say that this variable depends on all the other on all the other variable or only two of them, and you can create like these interaction models where you can say that this variable can interact with this one, and that's very common too for the world of R, and that's present in stats models. So let's do a short recap of what we have so far. We have Numpy, Matplotlib, we have Seaborn, we have Pandas, we have stats models, and we have scikit-learn. That's the basic stack for Python. But right now, we have a lot of different ways of taking advantage of the amazing language. And I'm going to talk about some of them right now. The first one I want to talk about is a library called Dask, D-A-S-K. Dask is a library that is super useful if you know Pandas. If you don't know Pandas, it may seem kind of weird because you won't understand the API because it's heavily based on Pandas. But the cool thing about Dask is that it will help you scale and create almost the same code, but that will work for big data, for gigabytes of information. And it also works with Pandas, scikit-learn, and Numpy. So if you understood the concept of the ecosystem from Python, then you can go to Dask and try to create bigger scale problems and solve them. You can scale in clusters with Dask. You can connect Dask to your cluster and you can run in parallel your computations, or you can take advantage of your own computer and use your different cores from your CPU. So that's a very interesting library that you should be aware of. There are not that many courses on Dask, but they have very good tutorials. They have a very comprehensive documentation. So even though we don't have that many courses or people are teaching Dask right now, it's not that hard to understand if you know Pandas. By the way, before going into a different library, I want to say that if you really want to understand all this ecosystem I just mentioned for Python, there are several ways for free, and some of them are paid to learn these libraries. I think one of the best places you can get started is Coursera and EDX. They have a lot of great courses in data science with Python or Python for statistics, and in most of those courses you're going to be learning all of these different libraries. Another good place to get started is a company I work for. It's called Emeritus, and we have some courses for that. We're working with Columbia, with Dartmouth, we're working with the MIT, and with Wharton, and we have different courses that can help you go from zero to a good knowledge about the libraries and data science as a field. You can find information at emeritus.org, O-R-G. In there you'll find information of these courses. And also you have a lot of good tutorials and blogs in Katie Nuggets or Towards Data Science, or even DataCamp. DataCamp is another place that you can learn these libraries I mentioned here, and it's very straightforward and not that expensive. Something right now has to be said, that all of these things are tools. Data science is not just use tools. And I think if you listen to the other episode I have on this podcast and videos, you see that I mentioned that data science is a whole field. It's a scientific field that you need not only tools, you need to have a science behind it. So you need to be able to understand a project. You need to get and understand the math behind the problems. And when you do have all of that and you have the context of what you want to solve, then you can get started on learning and thinking about these tools. Another good library you have that is very close to what Dask is doing is called Modine, or M-O-D-I-N, Modine. And the idea is very similar to Dask. It's just you change, and by the way, you can use Dask through Modine, so that's interesting. I mean, you can just have the best of both worlds. If you learn Modine, then you can use Dask. And one cool thing is that if you learn Modine, it's very simple and to scale your problems as well. I mean, if you're finding issues with your computer or your cluster, if you have more data and you're using Pandas, Modine is a very good way to scale. It's a very good way to scale your information. Again, I don't know any course that is using Modine because it's a rather new library, but they also have a very good documentation. Their code, as well as Dask, is open source, and you can find information about that. One library that I'm not going to mention in this episode is called Ray, and it's very similar to Dask, and Modine works with Ray as well. A third library I want to mention is called Rapids. Rapids is a library from NVIDIA, and it works with GPU. So it's the same concept as Pandas, but now you're thinking on GPUs. Why are GPUs important? Because they're much more faster than CPUs right now. If you do have access to GPUs, I think it's a good way to start learning Rapids, because it will help you a lot if you want to scale and you have a lot of computations that you know are intensive and you want to do them in parallel, but you know that in GPU they will be faster. One of the problems with Rapids right now is a very new library, and it doesn't contain all of the different functions you will see on Dask or Modine or Pandas. But I think it's in a very good path, and I think it's going to be very important in the near future. If you want to know more about Rapids, you go to rapids.ai and you'll find information about it. They have a very good documentation and good tutorials as well. Before going into libraries for machine learning, there's a very good library called BambooLib. BambooLib is a library that is it's like a version, it's like a desktop version for Python, something like that. It will add like this window to your notebook in where you can do stuff like you're used to doing in Excel, but is for Pandas. So it's a GUI for Pandas. It's a very interesting library, again, in a very early stage of development. But if you really want to, if you don't want to code that much and you want to use the power of Pandas, this is a good start. BambooLib. Okay. So I think it's time we move to the maybe more interesting part, the world of machine learning and statistics. So far, I've mentioned stats models, scikit-learn, and Numpy. With the three of them, you can create almost whatever you want. But there are great libraries right now that you can use to improve your models, your machine learning algorithms, and to take advantage of the state-of-the-art of machine and deep learning. I think the most important library we have right now for that is called TensorFlow. I think you may know about TensorFlow. You can go to tensorflow.org to find information about it. It's an amazing library by Google. It's open source also. And it may be the default library for deep learning. The library TensorFlow is something very similar to Numpy, with the difference that instead of creating vectors and arrays, as you call them in Numpy, you have tensors. And the concept of a tensor is very similar to the one of a vector, but more general. To give you an example, a vector is a rank 1 tensor. A scalar is a rank 0 tensor. So when they created TensorFlow, the idea was to support higher dimensional data, like images, videos, and all of these things that are not that easy to compress in just a 2D matrix. So when they programmed that, they realized that this library, that's the tensor part of TensorFlow, and the flow part is how the information is traveling through the tensors. And TensorFlow can help you create neural networks. And this is not an episode about deep learning. I think we'll have that in the future. But just a brief that deep learning is a field, it's like a subfield of machine learning where you can create deep neural nets that can help you train very hard problems and like solve very hard problems from computer vision, from text understanding, and for video recognition. And you have a lot. It's a whole world in itself, and we'll have a place for deep learning in data science now. If you want to learn TensorFlow, there are multiple ways of doing it. Google has a free course. I don't remember the names, like machine learning course, something like that. But if you search in the internet for machine learning free course Google, I think you'll be pointed to the TensorFlow course. You have a lot of different resources, and right now the API is huge. You have a lot of different things you can do with TensorFlow for object segmentation. You can do like music segmentation. You can search for images, for videos, for text. I think almost every problem you can solve with TensorFlow right now. I think the parallel of TensorFlow is PyTorch. PyTorch is also a very cool library. It's very similar to TensorFlow because it also works with this concept of high-dimensional information and neural nets. And you also have a lot of different courses for it. But I think you'll find more courses for TensorFlow. When people ask me what do they have to learn, TensorFlow or PyTorch, I think you have to learn both. I think both of them are very important, and you'll find different applications for each one of them. One of the cool things about TensorFlow and PyTorch is that if you learn those libraries, when you do that, the interesting thing you'll see is that a lot of the different papers that are being published in the world of deep learning and AI are implemented or in PyTorch or in TensorFlow. And that's super interesting because if you understand the libraries, then you can use all of these great papers you have for that. Another library that is very close to TensorFlow is Keras or Keras. And Keras is a library that started as a spin-off of TensorFlow and now is an official part of the community in TensorFlow. And it's a simpler way of using the TensorFlow for your deep learning algorithms. Keras is very easy to understand and use. It has this sequential model that is super simple to implement these hard and complex nets. And we may have a session for that in the future. But right now, just remember that Keras is a part of TensorFlow. So you may want to understand TensorFlow before going into Keras right now. There are more libraries that I want to cover right now. One of them is called Spark. And if you know me, you know I've been working with Spark for several years now. And we're in the verge of the version 3.0 of Spark. It's going to contain more things about deep learning as well. But Spark is a library that is written in Scala and Java, but has an API for Python. And this Python API is awesome. So if you really have big data, you can have terabytes of information and you have a cluster. I think it's even easier to use Spark than all the other ones I mentioned in the past. Spark is a general fast engine to work with big data. And it also has a good library for machine learning called MLlib. And this is distributed machine learning. And that's very cool because you can take advantage of all your computer power to use Spark to leverage your cluster to solve hard and complex problems using machine learning and like the state of the art of it. If you want to know more about Spark, I do have some articles on Spark. So if you search my name and Spark, you may find them. Our friend and I, 2 or 3 years ago, created a library called Optimus. And Optimus, it's built on top of Pandas, Spark, Keras, and TensorFlow. You'll find that as Optimus PySpark on GitHub. And it's an easier way of using Spark. So if you don't want to understand everything about the API, then you have the chance to work with Optimus. Don't learn everything you have to learn for Spark, because you have as like a closer API to Pandas, and it's easier to use. So with Optimus, you also have a lot of cool ways for cleaning data and to do easy in an easier way the machine learning stuff that you can do with Spark. There's another library called Bumblebee from my friend Argenis as well, and in this library you can plot your information from Optimus, and it's like your GUI for Optimus, where you can see your information while you're working with it, and if you're cleaning data, that's very important. Before finishing, I want to talk about two more libraries. One is called Dash, and Dash, I think, is the best we have in Python to do dashboards. It's not an easy library. I think that's important to say. You need to know HTML and JavaScript in able to really take advantage of Dash, but it's a very complete library for creating dashboards. And if you already know Pandas and scikit-learn, and you know Spark, and you know all of these things I mentioned in this session, you can take advantage of Dash to leverage and to deploy your models. And talking about models, you have the other library called MLflow from Databricks. And MLflow is a library that was created to manage the work life or work cycle of a machine learning project, where you can go from experimenting with different types of models to your parameters, hyperparameters, and you can even deploy your models with MLflow. I think it's in an early stage, but it's been around for like a year, 2 years, something like that. But it's getting more and more importance from different companies. More people are contributing into the actual code, and it's getting very, very cool to use. And it's not that hard to deploy a model in MLflow. There are other libraries out there that may be important. One of them is called Teapot and AutoKeras. Those libraries are for AutoML. I mean, that's gonna be more important in the future about the auto machine learning things. But you have Teapot and AutoKeras. And I think the final one is called H2O. H2O is a very good library for automated machine learning, and it also contains a lot of cool things like XGBoost. It's also a very good library for machine learning. So this is a very interesting library that you can use to do more interesting stuff with AutoML and machine learning as a field. So I know I discussed a lot of different libraries in this session, but this is to give you an idea that it's not only Pandas. You don't need to, okay, I will learn Pandas, scikit-learn, and that's it. I mean, it's a good start, of course. That's the things we learned before. But right now, we have a lot of different things that you can use and understand to be better and to create better models, to clean your information, to see your information. So I think you have to be aware of all these libraries I mentioned here. I'm going to put them in the newsletter. By the way, tomorrow I'm going to be publishing the newsletter with the information from this podcast. We're going to have the video on YouTube, and we're going to have the audio on Spotify, so you can see it again and share with your friends. So remember, every Thursday we're going to have the newsletter, and I'm going to put all the names for the libraries tomorrow in the newsletter. Send a note. So I've been asked here to send a note for the list of libraries. Please go to my profile tomorrow, and you'll find my newsletter. It's an article I'll publish tomorrow, and I'll be publishing there all the names of the libraries I discussed today, and even more of them. So that's the end of today's episode. I really hope you learned something new. And remember to follow us in our social media at Closter Team, and in here at LinkedIn are just at Closter. Thank you very much to my team, Gabriel, Eileen, and Hazel, to help me create this podcast and videos. And I'll see you next week. Bye-bye.